Alright, so today we're going to take a look at something called stoichiometry. Now, stoichiometry is the process of using the relationships between reactants and products in order to predict how much stuff is actually going to be made in a reaction. This is really important for chemistry and a number of other fields because it allows us to not waste any of our ingredients. It allows us to have exactly what we need to make a certain amount of stuff. For example, if we have a bike factory, we know that there's a relationship between the amount of ingredients and parts that we have and how many bikes we can make. For example, we know that there's 2 wheels required for every 1 bike frame to make 1 bicycle. So if in my store I had 40 wheels, I know that I could make 20 bikes by using another 20 frames. This means that I'm not going to go out and buy 21 or 22 frames if I don't have enough wheels. I need to know exactly how much of everything I have. So we're going to take a look at an example problem. Find one of your sheets that has at the top stoichiometry problem number 1 that matches this problem here on the slide. The problem is what mass of water and how many molecules will be made when 4.56 grams of hydrogen gas react with that oxygen. So here we're taking a certain amount of reactant and we're trying to find out how much stuff we can make with it. There's a number of steps to go along with this. You're going to have a little printout given to you in a bit, but for now follow along with the slide. The first step to doing this is to write the balanced chemical equation for the reaction described in the problem. So in the very first row of your table, there's a cell, a square, for each of the reactants and each of the products. I want you to write the balanced chemical equation for the reaction in this problem. Pause the video for a second and try to do this on your own. All right, you should have come up with 2H2 as a gas for the hydrogen, since hydrogen is diatomic, plus O2, because oxygen is also diatomic and it's a gas, to yield 2H2O as a liquid. That's your balanced chemical equation for the combustion of hydrogen gas to make water. The second step in these problems is now that we have the balanced equation laid out, we can fill in any information that's given to us in the problem into the cells where it belongs. So we're going to go back to the word problem itself, and we're going to look for any masses, any moles, or any number of particles that are given to us in the problem, and we're going to put them into the table. So from our problem, so far our table should look like this. We have the balanced chemical equation up at the top, and then we have 4.56 grams of hydrogen gas written into our table. Everything else, though, at the moment is blank. We don't know it. Step 3, the one bit of information that we can figure out that we don't need to calculate in any way is the formula mass for each of the reactants and each of the products. So we're going to go back. We practiced how to do this yesterday. We're going to find the formula masses of all of our reactants and all of our products in this case, and we're going to put it into the top row of that table. All right, so take a minute, pause the video, and try to find the formula masses for all of those reactants and all those products. When you think you have an answer, resume the video, check your answers against what I have in the table, and see if you matched. If you don't, look to your neighbor or look to somebody else at your table to see if it can show you where you went wrong. Okay, so for hydrogen gas, we should have come up with 2.02 grams because the formula of hydrogen gas is just H2, so it's 2 times the mass of hydrogen. We're not going to look at the coefficients at all. We ignore them completely when we're doing formula masses. Because remember, the coefficient tells us how many of those formulas we have, not the formula itself. For O2, you should have gotten 32.00 grams, and for water, you should have gotten 18.02 grams. So now that reduces the number of free spaces in our table, and all that's remaining is the row for moles, the row for particles, and then the other 2 masses. We can start calculating some of these because now we have the formula mass and we have a mass. So this is similar to the practice from review problems we did yesterday. We can now go to the next step, which is to use the mass we were given in the problem and the formula mass to determine the number of moles of that substance. So take a minute and try to find the number of moles now of hydrogen gas using the mass we started with along with its formula mass. Pause the video, try to get an answer, and when you think you have it, resume and check. Okay, you should have gotten 2.26 moles if you tracked your sig figs and came up with your 3 sig figs. Once we have this information, we can now figure out all of the other chemicals in our equation because we have what are called mole ratios. The mole ratio is the amount of one substance compared to another substance, and we find it by looking at our balanced chemical equation. So for example, in this equation, the balanced equation shows that for every 2 moles of hydrogen gas, because there's a coefficient of 2 with hydrogen, we need 1 mole of oxygen gas, because oxygen has an implied 1 in front of it as a coefficient. Those 2 moles of hydrogen gas and that 1 mole of oxygen gas will make 2 moles of water. So the mole ratio from hydrogen to water is 2 to 2. And the mole ratio from hydrogen to oxygen is 2 to 1. What this means, and the way we can use this, is that for every 2 moles of hydrogen we have, we're going to have half as many moles of oxygen. And for every mole of hydrogen gas we have, we know that we're going to have exactly the same number of moles as water. So take a minute and try to use those mole ratios to find out if we have 2.26 moles of hydrogen gas, how many moles of oxygen will we have, and how many moles of water will we make in this reaction. Take a minute, come up with your answer, pause the video, and then resume to see how you did. So if we have 2.26 moles of hydrogen available, you should have found that we need half as much oxygen because it's a 2 to 1 ratio. So if there's 2.26 moles of hydrogen, we should have 1.13 moles of oxygen that are used up in this reaction. Now, because the same ratio applies for hydrogen to water, it's an equal amount. If we have 2.26 moles of hydrogen gas, we should make 2.26 moles of water. The next step is, now that we have the formula mass of oxygen and the moles of oxygen, or the formula mass of water and the moles of water, we can do the reverse of what we did earlier and now find the mass of oxygen needed as well as the mass of water that is produced. So take a minute, use that formula mass as a conversion factor, and try to find those values. Pause the video, and when you're ready to check your numbers, resume. If you don't get the correct answers, check with your partner or the people at your table to see where you made a mistake. All right, so using our 1.13 moles of oxygen and its formula mass, we should have been able to come up with 36.2 grams of oxygen used up by this reaction. Along the same lines, if we have 2.26 moles of water and it's 18.02 grams per mole, we can produce 40.7 grams of water. The last steps that we have to do are to find the number of particles of hydrogen used up, the amount of oxygen used up, and the amount of particles of water produced. We can do this by using the moles and Avogadro's number, which is 6.022 times 10 to the 23rd things per mole. This number of things could be atoms, it could be ions, it may be formula units or molecules. It depends on what it is that you're talking about. So let's take a minute, try to convert the moles of hydrogen gas into number of molecules of hydrogen gas, the number of molecules of oxygen, and the number of molecules of water. Pause the video and give it a shot. Okay, by doing your calculations, you should have taken the number of moles and multiplied it by Avogadro's number to come up with the number of particles. For hydrogen, you should have gotten 1.36 times 10 to the 24th molecules available at the start of the problem. And then 6.80 times 10 to the 23rd molecules of oxygen are used up. And those together produce 1.36 times 10 to the 24th molecules of water. Our final step is to go back and double check all of our work. Take a minute to see if the total mass of your reactants matches the total mass of your products. It should be very, very close. It may be off by a decimal or two due to rounding with sig figs. So if we look at our example, we had 4.56 grams of hydrogen gas to start with, and we said we used up 36.2 grams of oxygen. If we combine those to get our total mass of reactants, we get 40.7 grams, which is the same as the total mass of our products. This is a good way for us to go back and double check our answers and make sure that all of the calculations we did during the problem all worked out. So now what I want you to do is to go back through the video and rewatch any parts that you found confusing. Make sure that you understand where all of the numbers came from and how we were able to do all of the calculations. Talk with the people at your table, work with your partner to make sure that everybody understands. When you have a good idea about what happened in this problem, I want you to turn to problem 2 and try to go through that one with your partner or with your table team. Once you have given it a shot, you have some answers down, there is a second video for problem 2 that you can go through together to check your work or to clear up any parts where you may get stuck.